So we last time we were able to derive formula for finding resultant vector. Now I want to show you another method you can use to solve problem in resultant vector. That is finding resultant vector. Okay. Now that other method is what we call triangular law. Triangular law of vector addition. Triangular law. So what does that law state? The law states that if two vectors represent the two sides of a triangle taken in order, the third side represents the result and taken in opposite order. Okay, so what it means, if we have a vector here, let me call this vector A. You have vector B in order to vector A, vector B. And we say the third side represent their result and taken in opposite order. So this is going to be their resultant taken in opposite order. We can call it C. All right. So if two sides of a triangle A and B represent the two sides of, if two vectors A and B represent the two sides of a triangle taken in order, the third side represents the resultant taken in opposite order. That is what that law says. All right. No, now having stated it, you can as well use your R square equal to F1 square plus F2 square plus 2F1 F2 cos theta to find your resultant, and then your sine rule, we say sine of angle A all over A equals sine of B over B equals sine of C over C to find direction. All right. So this the difference between the parallelogram law and triangular law is just in the diagram. That is the difference. Otherwise, you apply the same method, the same formula to solve problem. All right. So having stated that, we are going to move to what we call component of a vector. Component of a vector. Component of a vector. Before I go into component of a vector, I think it's important we define resultant vector because I noticed I omitted it while in the previous class. Resultant vector, we say resultant vector is that single vector that will have same effect both in magnitude and direction as the original vectors acting together. What it's saying is that if we have this vector acting with this vector, let me call this one F1, let me call this one F2. Their summation, the sum of both of them is what we call resultant vector. We said it is that single vector that will have same effect both in magnitude and direction as the two original vectors acting together. These are the two original vectors that are acting together. So this is their resultant. Now, what we are going to do in component of a vector is to split this resultant vector perpendicularly. In component of a vector, we are splitting this resultant vector perpendicularly. We are finding the value of this resultant in the vertical direction and in the horizontal direction, or in the northerly direction and in the easterly direction, or in the y direction and in the x direction. That is what we are going to do under component of a vector. All right. So let me define component of a vector. We say component of a vector is the effective value of a vector in any given direction. Component of a vector is the effective value of any vector in any given direction. All right. So just like I drew earlier, if I have this, this is our Fy and this is Fx. Okay, we have this resultant here. This is R. Can complete this diagram. Or instead of calling it R, let me call it F. F. Right? Now, usually we use angle made with the vertical, but we can, horizontal, but we can use any of the angle to solve. Okay. What I want to do here, this is our resultant force. I want to find the value of this force in the Fy direction and value of this force in the Fs direction. Okay. If I'm looking for value of this force in the Fs direction, I'm going to say cos theta, the side angle is made with takes cos, the other side automatically takes sine. So I'm going to say cos theta. Of course, we know that cos theta, that is car, is equal to adjacent over hypotenuse. Cos theta equals to adjacent, which is Fs, over hypotenuse, which is F. If we cross multiply, we are going to have Fx is equal to F cos theta. You can call this equation 1. So this is the value of this F in the Fs direction, in the horizontal direction, or in the easterly direction. Is that clear? So this is the formula to find the value of F in this direction. If I want to find the value of F in the vertical direction, I'm going to say sine theta, sine, that is so, is opposite over hypotenuse. Sine theta is going to be opposite. If here is Fy, here is also Fy. Opposite over the hypotenuse, which is Fy over F. If I cross multiply, I'm going to have Fy is equal to F sine theta. So that if we have the values, we can substitute and solve our problem. If we have numerical values, we can substitute and solve our problem. Okay, so this is how to find component of a vector. Remember I said earlier that component of a vector is the effective value of that vector in any given direction. So that is it. I will move into resolution of vectors that are more than 2. Just like as I said earlier, later on, we are still going to come back and solve problems, at least one problem in each of these, using past questions. All right. When you talk about vectors that are more than 2, we have resultant vectors put together, acting at a point. Okay. We can find their resultant. And there are ways to do that. You can use tabular method. You can use analytical method or formula method to find the resultant. Okay, now, for example, if we have this, let's say we have something like, we have a force acting here. We have a force here. We have a force here. We have a force here. Can call this F1. The angle with the horizontal is theta 1. Can call this F2. The angle with the horizontal is theta 2. Can call this F3. The angle with the horizontal is 90. Can call this one F4. The angle with the horizontal, the angle with the horizontal here, let me call it theta 3. Then I can call this theta 4. The angle here, let me call it theta 3. Okay, now for you to be able to solve problem under here, you must know your Cartesian plane. Okay, now if we want to find the F component, first and foremost, make use of only angles made with the horizontal. This is to avoid ambiguity. You can use any of the angles if you want, but to avoid ambiguity, confusion for students, just make use of only angle made with the horizontal. Okay, now if they give you a question and the angle is made with the vertical, subtract that angle from 90 to get the horizontal angle, the angle made with the horizontal. So now, in this case now, if I want to use formula method to solve for Fs, that is the horizontal force. If I want to solve for Fs, I'm going to know that all the forces on the right-hand side should be positive, and all the forces lying on the left-hand side should be considered negative for S component. All right? So for S component, which I now call Fx, my Fs is now going to be, starting from the first force. This is on the right-hand side. We'll call it F1 cos theta 1 plus, this one is on the left-hand side. So I will do bracket open, minus F2 cos theta 2, bracket close, plus, this is neither on the left nor on the right, so I'll consider it to be positive, plus F3 cos theta 3, plus, this is also on the right hand, is going to be F4 cos theta 4. Now, if I have the numerical values, I will substitute and find and sum it up. So that is going to give me the horizontal component of all these forces that are here. Is that clear? Now, if I want to find the vertical component for y component, Fy. Now, I told you that the side angle is made with takes cos. The other side automatically takes sine. So for y component, everything up, remembering, recalling your Cartesian plane, everything up is positive and everything down is negative. So for y component, we are going to have this, that Fy is going to be, starting with the first force, is up, so it's going to be it's going to be F1 sine theta 1, F1 sine theta 1, plus this one is equally up, F2 sine theta 2, plus this one is down, is going to be bracket open minus F3 sine theta 3, plus this is equally down, minus bracket open minus F4 sine theta 4. Okay? So if I have numerical values, I substitute and solve. This is going to give me the summation of Fy. All right? So that is one way to do it. Another way is to use tabular method to solve your problem. And that is very simple. In tabular method, I'm just going to do it briefly also. In tabular method, let me draw the table. Okay. You should have your forces in Newton, your angles in degree, your angles theta in degree, and then you have your x component, and then you have your y component. Okay, so your forces here are F1, F2, F3, F4. Right? Now the angles are theta 1, theta 2, theta 3, theta 4. Your S component is going to be F1 cos theta 1. This one is on the left, so it's going to be minus F2 cos theta 2. There's no point since there are no numerical values. So let me just put it this way. This one is neither left nor right, so consider it a positive F3 cos theta 3. This is right, so also consider positive F4 cos theta 4. All right? Your y component, everything up is positive and those down are negative. So we are going to have F1 sine theta 1. Okay? Then here, let me roll it. Then here we have F2 sine theta 2. It is also upward, so that's why it is still positive. Now we have F3 is downward, so it's going to be minus F3 sine theta 3. F4 is downward also, it's going to be minus F4 sine theta 4. So if you have numerical values, If you have numerical values, the values of f and theta, you substitute and find your summation. Find summation fs and summation fy. So with that, you'll be able to now find, having done that, you now find your resultant. Summation of fy, summation of fs, you now find your resultant using r equal to fx squared plus fy squared. Having found that, you now use your trigonometric ratio to find direction and you are done. Okay? So, thank you so much. In our next class, I'm going to be solving problems using all the formulas we have derived under this vector. I'm going to be solving problems and then also solving problems from past questions. Okay, so thank you. Please comment, like, and share. Follow my Facebook page, follow my TikTok page, Perfect Tutors Academy, and my YouTube channel, which is perfect_tutors/academy. Thank you so much. See you in the next class.